Well, hello again, everyone. Mr. Reeves back with you. And we're going to take some more time looking at the area of circles. In my previous video, we did some problems where we found the area of the circles given the radius and the diameter. Specifically, let me see if I can get there. I believe we worked through these three problems up here. So what I'd like to do in this video is do a little more problem solving with circles and explore some different problems beyond just the basic of finding the area. So one of the things that I've asked you to do, and I'm asking you because that's what the standards say you're supposed to learn, is how to relate circumference and area together. So given the circumference, can you find the area? And given the area, can you find the circumference? All right, so let's do a quick review of what circumference is. Circumference, again, is the distance around the outside of a circle, right? And the formula for circumference, let me see, circumference. The formula for circumference is C equals D times pi, right? The circumference is equal to diameter times the pi, or sometimes we say the circumference is equal to 2 times pi times the radius. Again, I talked about this in the previous video. When you multiply 2 times the radius, you get the diameter. We like to put the numerical part in front and the variable at the end. That's circumference, all right? And then the area, the formula for the area of a circle, A, is equal to pi times the radius squared. You square the radius and then you multiply by pi. We did say that you can also do pi times the diameter divided by 2. Sorry, that's not great over that writing squared. So if they give you the diameter, you can divide it by 2, square it, and then do pi. But again, as I said in the previous video, I just recommend that you always find r right off the bat and then just use this formula, pi times the radius squared. Remember, order of operations, we square the radius first before we multiply by pi. All right, so those are a couple quick reminders. So let's take a look at these problems here. Again, I'm working out of your textbook. This is not sure what page because I already got the screen here. Let me go out for a second here. So I am on page 274, right? All right, page 274 in your textbook if you wanted to be where I was. If you're following along and wanted to work in your book, that's where I am. All right, so it says find the area of each circle. Give your answer in terms of pi. So it seems complicated, maybe even a little scary that they have pi here, but they're making your life a lot easier actually. All right, because take a look right here. What does it say? Circumference is equal to diameter times pi. Circumference is equal to diameter times pi. So when it says that the circumference is equal to 4 times pi, what are they telling me? They're telling me that the diameter is equal to 4. Do you see that? The diameter is equal to 4. What about this one? The diameter is equal to 12. And this one right here is a little more tricky, all right? But pi divided by 2 is the same as 1/2 times pi. When you divide by 2, it's the same as multiplying by half. So here the diameter is equal to 1/2. Once you know the diameter, then you can find the radius, right? Once you know the diameter, you know what the radius is. Because as we talked about, the radius is just half the diameter. All right, remember when you have a circle, all right, let me go ahead and make a circle right over here, right? If you have a segment, if you have a line segment that goes all the way across the circle through from one end to the other, that is the diameter. And if you have a segment that goes part way through like that, that goes from the center to the side, that's the radius. And of course, you can see that the diameter is just simply 2 of those radii put together, right? So if the diameter is 4, the radius is 2. If the diameter is 12, the radius is 6. This one's a little more tricky. What's half of a half? If I have a half and I cut it in half, I hope you realize that you get a 1/4, right? So now I've done all the hard work because now I'm ready. The area of a circle, right, is pi times the radius squared. Well, what do I have right here? The radius. What do I have right here? The radius. What do I have right here? The radius. So the area is going to be pi times 2 squared, or pi times 6 squared, right? Or pi times 1/4 squared. Now they said to give our answer in terms of pi, so let's simplify this. 2 squared is 4, right? So it would be pi times 4. But like I mentioned over here when I was talking about, we like to put the numbers or the coefficients before the variable. So instead of pi times 4, we usually write 4 pi. If you wrote pi times 4, I would not mark it wrong. That is correct as long as you put the dot there to show multiplication. But if you put the coefficient first, you don't have to put any multiplication symbol. So 4 pi, and they didn't give us any units. Whatever the units were, they would be units squared. So this one right here, what is 6 squared? It's 36. So this answer would be 36 times pi. And what about this one? A fourth times a fourth. Well, you guys know what 4 times 4 is, right? It's 16. So I get 1/16 times pi, right? 1/16 times pi. So the answer to these questions is 4 pi, 36 pi, and 1/16 pi. So when they give you the circumference, you need to find the diameter, right? Now, they didn't do it, and I'm not going to make you do it, but if they had given it without pi, right? If we couldn't see this number, we would simply have to divide by pi, right? Because if I divide by pi, what's left? 4. If I divide by pi, what's left? 12. If I divide by pi, what's left? 1/2. But if I give you any of these problems, I'm going to do it just like the textbook did. I'm going to have pi there. Okay? All right, so I hope you could see that these problems aren't too difficult. I want to encourage you to get on the personal math trainer and try to find some of these problems and see if you can get them right, because I did all 3. There's none left for you to do. All right, so a circular pen has an area of 64 pi yards. What is the circumference? So this one's going the opposite direction, right? They gave us the area, and now they're asking for the circumference. So again, what is the formula for area? The formula for the area of a circle is pi times the radius squared, right? So do you see right here we have pi, and right here we have pi. So what does that mean? Well, what's the other part there? 64 and r squared. So if the area is 64 times pi, and the area is pi times the radius squared, what does that mean? That means 64 is equal to r squared, right? Well, what squared is 64? What times itself is 64? Well, we're going to take the square root of 64, right? Because the inverse or the opposite of squaring is square rooting, not division. And what is the square root of 64? I hope you know it's 8. All right, so the radius is 8. But it didn't ask us for the radius, did it? It asked us for the circumference. All right, here we go. Back here. What is the formula for circumference? It's diameter times pi, right? So we know that the radius is 8. So what's the diameter? Remember, the diameter is twice as big as the radius. The diameter is twice as big as the radius. So if the radius is 8, what's the diameter? Yes, correct. That is 16. And what's the formula for circumference? Diameter times pi. So the circumference we're looking for is 16 pi, because they did say to give our answer in terms of pi, so we can just leave pi. A lot of times they'll say to put in 3.14 for pi, but they didn't do that. And again, circumference would have units like inches or feet or meters, but we didn't have any units. Okay, so 7, 8, and 9, we were going from circumference to area. And number 10, we were going from, I'm sorry, yes, 10, we were going from area to circumference. So you need to be able to go both ways. So again, I encourage you, Personal math trainer, find the problem that matches with number 10 and maybe do 2 or 3 of those problems until you can do all these problems. All right? Okay, so that is one thing you need to be able to do. So let's take a look at a few more problem solving problems and then we're going to be done. All right, so here we go. Again, this hubcap one isn't really problem solving. It's just that's the radius, right? This one here isn't really problem solving. They gave us the diameter. We're looking for something where we have to actually do a little bit more beyond just finding the area. What about number 14? A stained glass window is shaped like a semicircle. The bottom edge of the window is 36 inches long. All right, so one of the things you are being asked to do, one of the things you are being asked to do is to find the area of parts of circles. All right, so I'm going to go ahead and make a whole circle first. All right, now a semicircle right here, that is half of a circle. So here we go. So right there, I'm going to cut that circle in half. So we are only looking at, and I'm going to go ahead and just do the top half here. We're looking at the top half of this circle, the colored part, okay? That would be a semicircle. So, it says a stained glass window is shaped like a semicircle. The bottom edge of the window is 36 inches long. So all of this going across is 36 inches long. Well, let me ask you, what does that represent of the circle? What goes from there to there? All right, right on. That is the diameter. So the diameter is 36. What are they asking us for? They're asking us for the area. Again, the formula for the area of a circle is pi times radius squared. So if we know the diameter, let's find the radius. The radius is what of the diameter? It's half of the diameter. Very good. So the radius is 18. So the area of the circle with a diameter of 36 would be that, right? But we only have how much of the circle? We only have half of a circle. Remember, they said it was a semicircle. That means it's a half of a circle. So I need to take this answer and I need to multiply it by 1/2. All right? By the way, another way you could do that would be to divide by 2, because multiplying by a half is the same as dividing by 2. All right, so I'm going to go up ahead and pull up my handy dandy calculator. I didn't have it open yet. That's my bad. So it's going to take a second here while we get our TI calculator up and running. Let me go ahead and hide this extra part here. Let me clear everything off the screen. That could go away. I don't know why that's still there. All right, well, it is what it is. Okay, so here we go. Oh, now it's gone. So we want to do this, right? Pi times 18 squared times a half. Now, the great thing about these calculators is they will do fractions, right? So here we go. So I'm going to do the fraction key, and I'm going to put 1 on the top, and I'm going to put 2 on the bottom. I think I'm going to put 1 on the top. There we go. Clear it out. Let me try this again. And 2 on the bottom. And then I'm going to arrow over here to make sure I'm out of the fraction. Then I'm going to go times. All right. Now, did they tell us what to use for pi? They did not tell us what to use for pi. All right, now, normally they've been saying to use 3.14 for pi, so I'm going to stick with that. 3.14 is not equal to pi, but that's our approximation, times, and then what was our radius? Our radius was 18 squared. So half because it's a semicircle. 3.14, that's our approximation for pi. 18 was our radius, and when we do that, we get an answer of 508.68. All right, so just in case you have a calculator that doesn't do a fraction or you're not convinced the other way will work, I just want to say we could have done it this way. We could have done 3.14 times 18 squared, right? 3.14 times 18 squared. Could have gotten that answer. That would be the area for the entire circle, and then simply divided that by 2. and you see that we get the same answer, 508.68. And the directions do say round to the nearest hundredth, 508.68, right? And to the nearest hundredth is 2 places, so we actually don't have to round. What were our units? Our units were inches, but area is always in square inches because we're finding the number of squares, as I said in the last video, that it takes to fill that lousy square. So inches squared or square inches. All right. So I hope that makes sense. So a semicircle is half of a circle. We knew the diameter, we found the radius, we found the area of the whole circle, and took half of it. All right, let's take a look at another question. How about number 16? A radio station broadcasts a signal over an area with a radius of 50 miles. A station can relay the signal and broadcast over an area with a radius of 75 miles. How much greater is the area of the broadcast region when the signal is relayed? Wow. I sure butchered that one, didn't I? Okay, so I'm going to need a little more space here. I'm going to make 2 circles, okay? So we have our first circle right here. And then inside that circle, I'm going to make a second circle. All right, about like that. Okay, now we have 2 radii, right? We have the smaller radius of 50. So I'm going to go from here to here. And that's the radius of 50. Okay, and then I'm going to use a different color. Where'd my green go? I'm wanting some green here. I'm going to pull up green. Here we go. All right, and then I'm going to go up here to the outside, and that one is going to represent 75. All right, so it has the broadcast signal that's blue. So the broadcast signal, right? The broadcast signal is blue, and then we have the relay signal is green. And the question is, how much greater is the area of the broadcast region when the signal is relayed? In other words, how much bigger is the area of the circle with the green radius than the area of the circle with the blue radius? All right, well, let's find the area of each circle. All right, well, it doesn't matter what size circle you have. The area of a circle is always pi times the radius squared, right? The area of this circle is always pi times the radius squared. What's going to be different is the radius. This one is pi times what? 50 squared. And this one right here is going to be pi times 75 squared. All right, so again, I'm going to go to my calculator here. And did it tell us what to use for pi? Again, it did not tell us what to use for pi, but most of the problems have been telling us to use 3.14 for pi. If I'm going to mark a question right or wrong on a quiz, I'm going to try to make sure I always tell you what to use for pi. And if I don't, I'll have to give you some variance in the answers that are correct here. Wow, look at all that stuff. I've been doing a lot of math here. All right, I'm not sure why. I think it's thinking. Look at that, it's flashing. It's not sure what to do. I pressed too many buttons. It's going crazy here. All right, well, let's just see if we can do this. All right, so I'm going to do 3.14. No, I'm not. I think my program may have just maxed out here. Delete, 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 delete. This is ridiculous. All right. You know what? I'm just going to close out my calculator and I'm going to start over. Sorry for this delay, folks. Looks like we got the same stuff going on here. View. Let's see if we can clear. Ah, there we go. Alrighty. Well, one of these days when I get good at video editing, I will edit this part out. I could have swore I just had it clear. Wow. It's freaking out on me. All right, let's see if we can do this, okay? Let's delete. Wow, clear, delete. 3.14 times 50 squared. 3.14 times 50 squared. 7,850. 7,850. And that would be what? What are our units that they gave us? They gave us miles, but area is always in square units. So that one is miles squared, right? All right, what about this next one? Let's do 3.14 times 75 squared times 75 squared. When we do that one, we get 1,000. Whoa, let's get that back, can we? 17662.5. 17662.5. And that one is going to be miles squared. All right, so the question was, how much greater is the broadcast region, that's the green one, than the relay region, right? The relay region is the green one minus the original broadcast one, which is blue. So if you want to know how much greater, you're going to subtract, right? So we really are trying to find out, if you think about it, we're trying to find out this part right here, right? This is part right here is the part we're trying to find. Okay. Ooh, can I go all the way around? Ooh. Wow, I don't think that was worth it, but we did it anyway. All right, so we're going to subtract. So I'm going to go back to my calculator. Now you'll notice this answer is already here, and I've shown you this before. This is how most scientific calculators work. I've got that answer, so if I simply put the subtraction key, it's going to take what I had, right, put that for the answer, and then I'm going to subtract 7850, which was the original area before they relayed it, right? And when I do that, I get 9812.5. 9812. I'm going to try that again. I do not like how that looks. Here we go. 9812.5 miles squared. Wow. So look how much more you get. Do you realize that that pink area there, that's a big number, right? It's bigger than what we got there. So obviously my drawing is not to scale because this pink area here is actually bigger than that white area there. All right, well, I'm going to go ahead. There are a few more problems that we could solve, but I'm going to stop this video here because it's gotten pretty long. So I'm going to make one more video that shows solving problems involving circles. Thanks for watching, everybody. I hope you learned a lot.